Okay, so this video is for teachers. If you're a student, please turn your computer off. And if you're a teacher, keep watching. So what I'm doing recently is I've taken in IAs from anywhere from USA to Europe, and I'm getting quite a few issues coming up with their reports on how they're getting set up. And I have to blame it on the teacher, I'm sorry. I even went to Science Teachers Association of Queensland in UQ, and the lecturer there at University of Queensland was teaching teachers how to do it wrongly. They were basically just saying, make up the questions in your head. Can you go with this question? How does this question sound? So it's just completely wrong. So I have to put the blame on teachers for getting taught it wrong or not knowing how to do it properly. So it's just basic scientific method. You never just come out of stuff out of the air. You always do your research, see what's done, and then base your new research, learning something new based off that. So the first thing they have to do is they have to change something. All right? It has to be something that's been done in the past, and then they have to show that they've changed it. So this is shown up quite clearly in the criteria. So evidence of personal engagement, independent thinking, creativity, justification for choosing the topic, personal significance, personal input. They need to show that they have basically seen what has been done, and then they've put their own slant on it, and they've done something that's different. They've changed something. That's how you get an easy full marks for that, and that's what science is all about. It's standing on the heads of shoulders. It's seeing what's been done. It's doing something else. And so if I go through the rest of the criteria and just see how that influences the rest. So this one here is now exploration. So if we want a perfect 6 for exploration, the topic of investigation has been identified and a fully and relevant focused research question has been clearly described. You can't do that if you haven't, you can't come up with a relevant question if you don't know what's been done. If you're just doing the vitamin C on oranges, well, that's not relevant because it's been done a million times before. If you're trying to work out, well, what's the vitamin C of this new GMO product? Does it decrease over time more significantly than other fruits? Well, that's relevant because it's new and you're expanding on the science. So that's how science works. So background information, that's your research again. And that gives you the context. The methodology, I've seen crazy methods as well. Your method will work because it's been done by this person and you're shown how to do it. And not only that, you're changing it because you're in a science lab is perfect. Is a perfect match for input, personal input, and creativity. So that completely solves that problem. So when I see teachers do it wrong, or the students can't get it to work. Even last year, one of my chemistry teachers, the students were saying it's not working. Well, I'm saying, well, why isn't it working? What was the previous research that was done, and it worked? If it worked for them, why is it not working for you? And they just come up with the questions out of thin air. And so they're basically, the whole experiment failed because they started off wrong. So you've got to base it on research. Now, even if you're not doing IB, you're doing the Australian ATAR, and they've dumbed it down quite a bit. It's still the same process. You're still doing an experiment that's done in class, and you've got to show how you've changed it. And so that it really doesn't change the scientific process whatsoever. You're still using scientific process even if you're in Australia. And so for the people in the rest of the world, and this goes for Google Science competition, you're not going to win a Google Science competition if it's not something new. And how are you going to know if it's new, and how are you going to get to that level if you haven't done the research? It's how science works. Let me just go back to the other points here. I was going to pull up a student report, and I've got permission for at least one student, but I don't know if I'm going to go through with that. I'll just go through these points here. So if you can't see the report and what they've changed, well, I'm blaming the teachers because you've probably got small classes because it's chemistry, all right? So it can be anywhere from 1 to 2 to 6, possibly, typically maybe 12, 16. I've heard some teachers have large ones of 33. This is worth 20%. All you have to do is conference with them. And if they haven't got a research article to base it on, and I was doing this for biology too, you just say, nah, go back, you're not ready to start. So all of these 4 things, I'm getting reports from students all around the world, so the teachers from all around the world, and they don't have these things, and I'm thinking, well, it shouldn't just happen. I don't let it happen. This one's a point that you can grab onto later, so it's probably not as critical. But the kids don't explain it with IB concepts, and so they need that. But let me get on to this one. Range of 5, repetition of 3. I will go into a student report just to demonstrate some of these things. A drop counter for titrations, I think it costs a few hundred, but I know that's nothing for a science budget, paying a couple $100. Spectrophotometry is the best because they're quite cheap, those machines, and you're going to get lots of good data and you can measure pretty much anything. So spectrophotometry is where you should be heading, and just one independent and dependent variable. I think a lot of students, they just try and make it too complicated as one of their problems. So if I go here, so the report concludes sufficient and relevant quantitative and qualitative raw data. I have a template that explains that covers a lot of these bases, but quantitative data, you need data loggers. That's how the world works. Even in biology, I was out in the mountains and I saw some data loggers being set out with a little card there with a plea saying this is for PhD research, don't take it please. And I didn't take it. And they were trying to measure the temperature for frogs and stuff. So everything's done in data. No one actually takes data. The computers do it all. They're probably sitting in a university lab somewhere and they probably know what the temperature is every second. All right, it's probably being relayed to their cell phone or something. So data loggers are the only way to go. No one does titrations. The machines don't work off that anymore. They do it automatically. You don't do it yourself. So appropriate sufficient data processing, that's getting now. You can't do appropriate sufficient data processing if you don't have the data. So range of 5, repetition of 3. The rest is the processing part of it. So what is detailed is described, justified and described. That's why I talked about IB, and it needs to be clear. So this whole last bit's just going to crash if you don't get the first bit right. So let me just go to a student example. I've got permission. Now this is not by any means one of the worst ones I've seen, but this one really annoyed me because, okay, fair enough, they haven't done, the whole thing is about comparing how well two different solvents take aspirin out. Where's the range of 5, the repetition of 3? I dare say, I'm sorry, it's probably going to be impossible to get a 7. The student told me, well, my teacher said I could do this, and the teacher even gave me the method, which is like, that's exactly what they're not meant to do. It doesn't matter what your teacher says, that's going to get sent off to IB for moderation, and then the IB moderators will say, no, that's not a 7, it's a 6, and everyone has to decrease their mark by a grade, and it happens, I'm sorry. So I don't care what your teacher says, the IB will say, nah. No way. And the method itself, this particular method, I looked it up, it is so detailed, and they didn't include some of that detail. They could have just literally cut and paste. So this one by Lewis, he even suggests how to do an IA properly. So you could do a range of 5 by mixing, and I've had students do this before. There's 2 different solvents. They could have mixed various concentrations, so 25, 75, 75, 25, 50, 50, 10, 90, whatever, make it increments. So they could have got a range of 5 that way. It's too late now, and so they've already done it. The only thing I'm thinking that can save them, which is I suspect the dodgy writers are, because there's this dodgy video on YouTube about how to write one in 3 hours, and I'm thinking, well, is he writing them for them in 3 hours? And that's impossible. Probably takes 3 hours to get a good research question, and then you're set, and then you're going to get a good mark. But you could mix them, and then there's 2 independent variables here. And as I said, this is just super typical. I'm getting lots of these. Where they're just trying to make it too complicated. You're not going to be able to get a relationship you can talk about if you don't have a graph that just has one independent and dependent variable. See if it curves, goes straight, whatever. All right, that's what you should be aiming for, not just a simple comparison of 2 things and you don't have a relationship there. You can talk about it. I'd say 6 at the most if he does these fixes. And so that is one of the issues there. The other thing that really frustrated me with this particular one was he didn't. Where are we? Oh, the teacher let them do this aspirin, which is number one, it's organic, so it's way too. So I always veto nothing organic, and of course IB experimentation policy, nothing to do with animals or humans or whatever. And so it's organic, so no, number one, no. I tried once, because it was an extended essay, to let a student do perfumes using distillation, and I regret that, because it pretty much almost failed just because it took too long. Don't do anything that takes you more than 5-10 minutes to do a trial. Even that is questionable. Once you've got your things set up, should be really quick and easy using data loggers. Otherwise, you're not going to get it done in 2 hours or so. You're not going to get 15 trials done in 2 hours. The second thing that annoyed me was that the teacher just let them through. You're the teacher. Stop it. Don't let them have it. If they don't have a range of 5, just don't let them do it. Just say, where's your range of 5? You can give them ideas of how people do ranges of 5. The repetition of 3, you can get away with 2 if it's a dead set titration, but I wouldn't. I just use a drop counter and do it properly. And the independent dependent variable, the teacher should be vetoing these 3 points, and so I shouldn't be receiving. Because I do a free IA check on my website. I shouldn't be getting these things from students. The teachers should not have let it through. So please do your checks and do your vetoes. Just say, no, this is how you do it. Fix it. Change it. It doesn't have a range of 5, repetition of 3. There should only be one independent dependent variable. Can you explain that with your IB concepts? And where this is your method, how is that different from the method that you looked at? And why did you change it? If you do that, it sets them up. It sets them up to be able to get a 7 and do the rest correctly. All right, thank you.